Alrighty, so we looked at with the Twizzlers that the radian measure of an angle is defined by the ratio of the length of the intercepted arc with respect to the radius of the circle. So let's take a look. Here is a circle, of course. The angle itself, this one is 1 radian. Notice the length of the arc, I to t, is 6 centimeters, which is the same as the radius. And if we would drag that around to go out to 2 radians, over here, notice the length of the arc is 12. 2 times 6, that's all it is. That's again how we get the radius, the radian, based on the radius. So this angle is how many radii, length of that many radii. So that's where we get that from again. So okay, so we could use either form. Theta, which is the angle, is arc length over the radius, or S equals R theta, sometimes better. Now, we know that one rotation, one time around the circle, turns out to be 2 pi radian. If I get that little bit here, go the other way. There, 2 pi, 3.14 times 2. So, and again, if we multiply the length is 6 times 2 pi, or 6 times the 6.28. There we go. So that's where we get the circumference from. So okay, so when we go ahead and do a lot of these here, we get stuff like this. So what is the length of the arc intercepted by the angle of 2.3 radians? Well, I'm going to use one of the forms. Since I'm looking for the length of the arc, I'm going to use the nice one here. The arc length, that's my S, is R theta. So that arc length is the radius times 2.3. Now, radians really don't have a unit on it. So 27.6. Because when you look here in the units, so the length of the arc and the length of the radius would have the same unit. So that's, so let's say if it was inches over inches, there's nothing in here. So radians don't really have a unit when we put it on there. Okay, so come down to here. What's the radian measure of the sun? Oh, that would be centimeters. Gotta put the unit. So radian measure of the central angle. So this time, what's the measure of that arc? What's the measure of that angle? So the arc has 25 millimeters. Circle has a radius of 125 millimeters. So we'll use since we're looking for the angle, the radian measure of the angle, theta is S over R, arc length over radius, so 25 over 125, 1/5 radian, only because we know it's an angle. That's how we know that that unit is. No other way. Okay, so that's a lot of times. Okay, blah blah blah. How about this stuff? This is where we really get into the nitty and gritty, why we use this and where we use this stuff. So we got a pulley of 6 inches, radius of 6 inches. So we've got this around here and 6 inches, and we've got a rope wrapped around it. Let's say something like this here, and comes down. So there may be something holding on to this down here, and we're going to take and pull that rope that way. Okay, now this pulley is going to turn 4.8, so somewhere about there, let's say, radians. So again, if the rope doesn't slip, how much does that go up? How much rope is wrapped around that pulley? Well, that's really just the arc length. That's all that it really is what's the arc length of. Because that rope is wrapped around the arc of that circle as we go around it. So that's just 6 times 4.8, or 28.8 inches. So when we're talking, especially if you get when you get to physics and you start talking about rotation, motion, this is the kind of stuff you're looking at. Okay, same kind of thing. What's the difference? Ratchet? In other words, not being a smooth. This has a ratchet. Sort of looks like a gear, but it's really not a gear, because a gear would be hooked up to another wheel. This is a ratchet, like a sprocket, with little individual sprockets, sort of like for a bicycle. And instead of a smooth rope, there's a chain wrapped around it. So maybe the chain's wrapped like this and heads off someplace else. So this time we know 75 inches of the chain. So the chain, so let's say we start here. This piece right here gets pulled 75 inches. Really, when you think about it, is 75 inches of the chain gets wrapped around that circle. Again, that's the arc length. That's really S. So this here is really the arc length. And the radius still is the radius. So R is 2.5. So by writing this down, the given, we can figure out, oh, let's use, again, how many radians? What's the turn? How much did this turn as we go along? How many? Okay, so that would be the theta. S over R. Again, inches over inches, no units. So 70 divided by 2.5, and we get 30. 30 radians. That's okay. Now, wait a minute. That's much more than 2 pi. 2 pi is like, again, 6 1/4. That just means this has gone around multiple times. Almost 5, when you think about it. Okay? So, here's some other thing. Extra weight, there we go. So now let's look at what's going on here. So the wheel is turning around. Got a wheel here, and it's rotating. Doesn't matter clockwise or counterclockwise in this case. So it's going around 45 radians per minute. So yeah, that's spinning around like this. So it incorporates 45 radians per minute. We need to figure out in rotations per minute, or revolutions per minute. Same idea, revolution and rotation. The main difference between them is when you talk about something in astronomy with a rotation on an axis and revolving around its own axis and rotating around the sun. A slight difference. We don't care right now for that. That's not. So really, when we look at this in 45 radians per 1 minute, really all we've got to do is convert this radian to revolutions. It's just a conversion. Now this is again the way I write the conversions. So let's see, there were 2 pi radians in 1 revolution. Now you may remember in your science class writing it this way. Instead of looking like a fraction, setting it up with stuff like this. Writing it like that. Either way is fine and dandy for me. Again, I know both. I still like seeing it this way because it looks more like a the fractions what you're doing. And unless it tells you differently, when you on something like this, it's not gonna, if it doesn't look nice, sometimes it might be nice, but if it doesn't ask for anything, you can go ahead and round to 3 decimal places, or 7.162 revolutions per minute, or RPMs. So that's how many times it goes around. And again, 45 radians is how many revolutions. And since we didn't deal with any change in time, that's what we're talking about. So this rotates a little over 7, well, little over 7 1/8 times around every 1 minute. Okay. Now, 6. So we know, okay, we get a miles per minute. Now, what's that? Well, how do we get miles? Well, think about it. A truck tire. As it's rotating around and around and around and around, what's it doing? It's traveling that way. So this length, this linear length, is really just that tire going around and around and around and around. So if we would take that 2.5 miles and wrap it around the tire, that's the arc length. So it goes 2.5 miles around and around and around and around and around in a minute and a half. So this 2.5 miles is the length, the arc length. Okay? So really, S is 2.5 miles. Now, problem with this is we have 28 inches. We got to convert miles to inches. I don't want to convert the other way because that'd be pretty minuscule. So, to convert that, 2.5 miles, I'm still going to go ahead and go in 1.5 minutes, just because it matches. We can do it at once. I don't know how many inches are in a mile. They're what, 5720 feet in 1 mile. Not sure, look it up. Oops, mile. So mile and miles are gone. And there's 36 inches in 1 foot. 36, sorry. 12. That's because when I originally did it, I did it in yards. 12 inches in 1 foot. So feet are gone. So again, this is just your arc length. So how many inches now around the circle divided by time. Okay, so we have inches per minute. Well, how many inches then are in 1 revolution? Yes, in 1 revolution. Well, that would be, okay, so there's S. We would have to go, there are 2 pi r inches, whoops, r, the radius of 14 in 1 revolution. In other words, the circumference in 1 revolution. So now we have the number of revolutions per minute. So multiply across the top again. If you have got it inspired, this is where that fraction bar makes a huge help. 2.5 times 5720 times 12, and then we're dividing by 2 times pi times 14. So that's just this. Oops, I got to multiply by the 1.5 in the denominator. So the tire rotates at 13